Hey there, Algebra 1, second period. We're going to, again, talk about 3.4 and 3.5, which is that slope and graphing lines. As a reminder, you want to go ahead and write down anything that I write down here. You can pause the video anytime you need. Let's remind ourselves of what we had yesterday. Slope, or excuse me, 2 days ago, slope. It's the rate of change between any 2 points on the line. Right? Any 2 points. So we were going ahead and counting some boxes yesterday. We also defined slope. We said, hey, it's the change in y over the change in x. If we want to do that with math terms, we would say delta y, and delta means change in mathematics, over delta x. Now the formula that we're going to use today is we're going to use y2 minus y1 is over x2 minus x1. This is what we call our slope formula. It's how we can calculate slope from 2 points, and that's what we're going to use today. So let's start off with a graph here. Let's start with example 1. And you're going to go ahead, hopefully you have a straight edge around you. We're just going to plot some points really quickly and draw a line. So I'm going to start by plotting the points. -5. So we have 1, 2, 3, 4, 5, -2. So -5, -2. And then I'd also like you to plot the point 5, 6. 3, 4, 5, 6. Okay. So this is the point 5, 6. This is the point 5, -2. Take your straight edge and draw a line through it. There we go. There's a line. Put little arrows on there. All right, so those are the points that we're working on. And yesterday, or whenever I saw you in class, which was, we talked about counting the difference between the 2 points. So here we go up 1, 2, 3, 4, 5, 6, 7, 8, up 8, and to the right 10. So that's how we counted slope the other day, is that we went up 8, and to the right 10. So if I calculated my slope, I would have said, hey, my slope is 8 over 10. We, of course, would have reduced that to 4 over 5. Okay, so that's one way that we could go ahead and do it, and we get the slope of 4 over 5. But if we just wanted to go ahead and I said, can you please calculate the slope between the points -5, -2, and 5, 6, what we could do is we could actually use our slope formula. And we'd take these 2 points. So I'm going to start with the points -5, -2. It doesn't really matter which one you start with. You just have to define one as x1, y1, and our other point is going to be x2, y2. It doesn't matter which one you start with because you just have to find the difference between them. All right, and as a reminder, that slope formula is y2 minus y1 over x2 minus x1. So what we're going to do is that we are going to take 6 minus -2. So we're going to say our slope is equal to 6 minus -2. Watch your negatives. All over, oops, my eraser got in there. All over 5 minus -5. All right, now we're going to go ahead, we're going to calculate this. So 6 minus -2 is actually going to be 6 plus 2. So 6 plus 2 is 8 over 5 plus 5 is 10. Hey, that's exactly what we got. But we, of course, would reduce, and we would say our slope is equal to 4 over 5. And that's how we do it mathematically. is that you simply just take your y points and you subtract them over your x points that you subtract them. So we started off with the graph, this graph over here, and we counted our slope, but sometimes we aren't able to count our slope and plot our points. All right, sometimes we just have to go ahead and we find it mathematically, meaning we take our y's minus our y's, x's over our x's, and you put them in a ratio. All right, let's try it again, but this time we're just going to give you the point. So for example 2, I would like you to calculate the slope between the 2 points I'm going to give you are -5, 3, and 6, 5. All right. So once again, it's always a good idea to kind of define what's going to be your x1 and your y1. You can take it however order that you want, but you have to make sure that you go in the same order. So I'm going to go 5 minus 3, and I encourage you to draw arrows to remind yourself which order that you went in. So 5 minus 3. And then I'm going to go 6 minus -5. All right, so 6 minus -5. We can go ahead and calculate this. This is 2. 6 minus -5 turns into a positive over 11. And that's just fully reduced. So that's actually just your answer right there. It's as simple as that, is that you can go ahead. Sometimes you have a finally totally reduced fraction. So my slope here is 2 over 11, meaning that the difference is up to over 11. That's it. That's all you need to do. So let's try it out for example 3. I'm going to ask you to calculate the points between 0, 7 and 2, 3. So again, you're going to go in whatever order that you want. I always like to draw those arrows. So 3 minus 7 over 2 minus 0. And we're saying we're calculating for slope here. That's going to be -4 over 2. We would reduce that to -2 over 1. As a reminder, we don't write those whole numbers over 1. So our slope here is -2. Now let's pretend that we wanted to go in the opposite direction. So 0, 7 and 2, 3. You wanted to go ahead and start with your other point. That's okay. You always need to start with your y's. So we're going to always start with the y point. So 7 minus 3 over 0 minus 2. 7 minus 3 is 4, 0 minus 2 is -2, and that still reduces to a 2 over -1, which is -2. So same thing. It doesn't matter which order that you go in, but you do need to go in the same order, so you have to decide which point you're going with. You can't flop them up and switch in between them. All right, let's talk about two special cases that we went over the other day too. These are special. So for example 4, we're going to calculate the slopes between 6, 8 and -1, 8. All right, so again, draw those arrows. So I'm going to go 8 minus 8. My slope is equal to 8 minus 8 over -1 minus 6. All right, 8 minus 8 is 0, -7. 0 divided by -7 is equal to 0. So my slope is equal to 0 here. That's totally fine. My slope is equal to 0, which we know if we have a slope that's equal to 0, this is a horizontal line. And if it's a horizontal line, the equation of the line is going to be y equals that y point. So y equals 8. As a reminder, the equation is different than the slope. So equation is different than slope. Slope is part of the equation of the line, just like the windows are part of a house. But the house and the windows are two different things. Your other special case is going to be example 5, and that's going to be 3, 5, and 3, 1. again, draw those arrows. So my slope here is equal to 1 minus 5 over 3 minus 3. 1 minus 5 is negative 4 over 0. Uh-oh. Oh no. Cannot divide by 0. So if you get 0 on your denominator, this is what it means, is that your slope is what we call undefined. It's not a number that we can work with right now. It's undefined. And our slope is undefined, so this is my answer right here. My slope is undefined. What we know about it is that this is a vertical line. And again, that equation of the line is going to be now x equals, and we're going to look at our x values. Those x values are 3, so x equals 3. That's the equation of the line, as always. Your slope is undefined. Your equation is x is equal to 3. So the last little tidbit that you need for your homework tonight is just finding the slope from an equation. So you might have something like negative 5x plus 15y is equal to 1. We're wondering, what is the slope? So what we need to do is we need to change it to slope-intercept form, which looks like y equals mx plus b, and then look at that slope value. So on our equation, we're going to add 5x because we want to solve for y. I'll put a little star there. Solve for y. Use those little equation skills. 15y is equal to 5x plus 1. I'm keeping that variable up front. Divided by 15. And the equation of the line is equal to y is equal to, let's reduce that fraction, 1 over 3x plus 1 over 15. So my slope here is 1/3. So my answer to this question is my slope is equal to 1/3. The equation of the line, of course, is y is equal to 1/3 x plus 1/15, but the slope of that is 1/3. All right, Algebra 1, great job today. I will see you soon.